Good day, everyone, and once again we are back together. All right, so we are looking at momentum, work, energy, and power. This is question 5 from the IEB November 2022 exams. All right, so in this case, if you have not subscribed, please just make sure you're part of the family. All right, so let's get right into the question. So they say to us, we've got two blocks to the right along a frictionless surface. Okay, they say block X has a mass of 2 kilograms and is traveling 3 meters per second. Block Y has a mass of 5 kilograms and is traveling at 1.5 meters per second. Right, they say the blocks collide. And block Y continues in its original direction with a speed of 2.5 meters per second. Right, so we know in this case what happens afterwards. They are simply telling us that block Y will still continue in its original direction. Okay, so this time it would be moving at 2.5 meters per second, right? All right, so they say to us, determine the velocity of block X after collision. So we are looking at momentum here, or in this case, the conservation of momentum. So what we're simply going to say is that the sum of momentum initial will be equal to the sum of momentum final. They are momentas rather final. Okay, so we've got block X, so that's mass of X, velocity of X initial, the mass of Y, velocity of Y initial, and of course afterwards we've got X velocity of X final plus the mass of Y times the velocity of Y final. All right, now let's substitute what we can. Right, so we are assuming that going to the right is our positive direction. Right, so in this case it's going to be 2 multiplied by a positive 3 plus we've got 5, which is Y, times positive 1.5. This is equal to, again, the mass of X is 2. Now we wanted the velocity of X after collision, right? And we know that Y is 5, but the velocity of Y after collision is 2.5, and it's still in the original direction, so it would still be maintained as positive. All right, so we're just going to take some gymnastics there mathematically, right? Okay, so it's going to be 2 multiplied by 3, right, plus 5 times 1.5. Okay, I get 13.5. I'm going to subtract, because when I take this to the other side, it becomes a negative. So I'm going to say minus 5 times 2.5. Okay, and that gives me 1. Okay, and in this case, that means 2VXF will be equal to 1. And of course, we can divide both sides by 2. And that will give us 0.5. So it means the velocity of X after collision, right, will be equal to 0.5 meters per second. And you must keep in mind this is in the original direction. So I'm just going to write there to the right. Okay. Or you can say, eastwards, right, just to indicate that direction there. All right, now let's quickly have a look at the next question. Right, they say, explain which block, if either, experiences the greater force during the collision. Right, now please, I want you to note in this case, this is an application of Newton's third law. Right, that if body A, in this case body X, exerts a force on body Y, then it means body Y will exert an equal but opposite force on X, right? So in this particular case, it means that the forces will be equal but opposite. All right, so the forces will be equal, equal but opposite, according to Newton's third law, right? To Newton's third law. All right. Okay, right. Now they say to us, explain which block, if either, experiences a greater change in momentum during the collision, right? Now I want you to please note in this case, remember, when we talk about change in momentum, what would cause the change in momentum? It would be the collision itself. And so I want you to note what we said is that the momentum before collision is equal to the momentum after collision, right? So which of the two experiences a greater change in momentum? Well, neither one, right? The change in momentum will be the same, okay? The change in momentum so will be the same for both objects, right? For both objects. And why is that? Because we know that by definition, impulse multiplied by delta t is equal to the change in momentum. Now I want you to note, we said the force that they experience is the same. It will occur during the same period for both of them. So which means the change in momentum should be the same. Okay, right, now let's go to the next question. Right, now they say to you, define impulse. Okay, so remember, we said impulse in this case is a product of a force and a period over which that force acts on a body, right? So I will just give you the formula, right? So it's the product of a force and the period over which that force acts on a body, right? And 5.5, they say consider block Y moving after collision, right? Calculate the magnitude of the force that will be required to stop it over a period of 0.2 seconds. Okay, now I want you to think about it. So block Y, we found out that block Y moves at a speed of 2.5 meters per second, right? So we want to stop block Y. So we first need to find out, right? What would have to be that force that would cause block Y to stop? Now think about it. We've got velocity initial, which was 2.5 meters per second. Our final velocity, we want that to be 0 meters per second, right? And we want that to occur within 0.2 seconds. Right, now I want you to note in this case, what is acceleration? We know that's going to be the change in velocity divided by the change in time. So that will be final velocity, that's 0, minus 2.5 initial velocity divided by the time lapse between the two, which would be 0.2, the one that is given there, right? So I'm going to have negative 2.5 divided by 0.2, okay? And our acceleration is negative 12.5 meters per second squared. And remember, when we talk about acceleration in this case, of course, it is negative because we are slowing it down. It's called deceleration, right? So in this case, it should be negative, right? But we wanted to find out the force. So this would be F net is equal to MA. So that would be the stopping force. Okay. That's going to be the mass of block block Y. All right, what was that mass? That was 5 kilograms, right? So that would be 5 multiplied by negative 12.5. And so that would give us, in this case, 12.5 multiplied by 5. Okay, so that will give us a force of negative 62.5 newtons, right? So it will take a force of 62.5 newtons in the opposite direction, but they did say they wanted the magnitude, so that will be 62.5. Another way we could have done this, we could have used that momentum impulse formula, which is change in P, right? We know the mass was 5, the velocity 0 minus 2.5, okay, because we wanted the force, that would be multiplied by 0.2, and this would have been much easier or much quicker to get to that final answer, right? Okay, so you'll get exactly the same answer there. All right, ladies and gents, it is an opposing force of 62.5. All right, as I said, I will continue to be giving you guys these questions, right? We're going to be doing work, energy, and power next again, right? So please keep looking out for these questions. I'll see you guys next time. Sharp.